Okay, let's take a look at this problem here. We got f of x is equal to x squared, and I'm going to take that e to the x up on top, e to the negative x. Just because I like the product rule better than the quotient rule. Okay, so we need the relative min, relative max, so we got to find our first derivative. So this will be p, this will be q. We need p prime. Derivative of x squared is 2x. We need q prime. The derivative of e to the negative x is e to the negative x times the derivative of the exponent, which is negative 1. So q prime is going to be equal to negative e to the negative x. Now our formula is p prime q plus p q prime. So for our first derivative, p prime is 2x times q, which is e to the negative x, plus p, which is x squared, times q prime, which is negative e to the negative x. Now I'm going to factor out what am I going to factor out? An e to the negative x and x. That x is gone, that e to the negative x is gone, so we got 2 here. One of these x's is gone, so we're left with a single x there. But that minus is there, so it'll be a minus x. And this e to the negative x is gone. Okay, now to find the critical values, we set this is already factored as much as it can be, so set each factor equal to 0. So I got x equals 0, e to the negative x is equal to 0, 2 minus x is equal to 0. Now here, e to a power can never equal 0, so that drops away. So we got x is equal to 0, and here take negative x over, it becomes positive x, and we get x equals 2. Now we want to plug that into our table. Over here is negative infinity, over here is positive infinity. We want to pick test cases. Something between negative infinity and 0, like negative 1. Something between 0 and 2, like 1. Something greater than 2, like 3. We want to plug them into our first derivative, and this is good place as any. Now one thing to keep in mind is that e to the negative x is always positive, so I don't need to plug it in there. I'll plug a negative 1 in for the x here, so I'll have a negative. Let's try that again. There, negative. And if I plug a negative 1 in here, 2 minus a negative 1 becomes 2 plus 1, so that's positive, which means this is decreasing. If I plug 1 in here, that's positive. And if I plug 1 in here, 2 minus 1 is positive. So positive times positive is increasing. And I plug 3 in here, that's positive. If I plug in 3 here, 2 minus 3 is negative. Positive times a negative is negative, so that's decreasing. So this is a min, and this is a max. Now, where they get the y part is you then take the x equals 0 and x equals 2, plug it into your original problem, and see what it gives you decimal-wise, unless it gives you an exact value. Now, our inflection point. And almost be just as easy to multiply the x through, but I'm going to leave it in that form. X e to the negative x, 2 minus x, so I'd lie. I'm going to go ahead and multiply the x through. X times 2 is 2x. X times negative x is negative x squared. Okay, so this will be my p and this will be my q. So I need p prime, the derivative of e to the negative x I found right over here. It's negative e to the negative x. Q prime, derivative of 2x is 2 minus x squared becomes 2x. So our formula is p prime q plus p q prime. So for our second derivative, p prime is negative e to the negative x times q, which is 2x minus x squared, plus p, which is e to the negative x, times q prime, which is 2 minus 2x. negative, and I can factor an x out of here. That's negative x, e to the negative x, 2 minus x. I can factor a 2 out of here, and that gives us 2e to the negative x, 1 minus x. Now, I want to factor out a e to the negative x, and that's going to give us negative x times 2 minus x plus 2 times 1 minus x. So that gives us e to the negative x. Negative x times 2 is negative 2x. Negative x times negative x is positive x squared. 2 times 1 is 2. 2 times negative x is negative 2x. So we got x squared. Negative 2x is negative 4x plus 2. Now to find our critical values, we set each one of those equal to 0. And of course, e to any power can never equal to 0. So this one I'm going to use quadratic formula on. So I got x is equal to negative b, so negative 4 plus or minus b squared. So negative 4 squared, b squared minus 4 times a times c, all over 2a. So that's going to give us 4 plus or minus square root of 16 minus 4 times 1 times 2 is 8, all over 2. So that gives us 4 plus or minus square root of 8 over 2. Now 8 is 2 times 2 times 2, so I can bring a pair of 2's out as a single 2, all over 2. And I can divide these 3 by 2, so it gives me 2 plus or minus 1 square root of 2, or just square root of 2. Now if I plug these in, 2 plus square root of 2, that's where they get the 3.41 at. And if I do 2 minus square root of 2, that's where they get the 0.59 at. So that gives us 0.59 and 3.41. Then we want to build a table of intervals. I got 0.59 here. Over here is negative infinity. 3.41, and clear over here is positive infinity. I want to choose test cases. Something less than 0.59 like 0. Something between 0.59 and 3.41 like 1. Something greater than 3.41 like 4. Now I want to plug those in to my second derivative, which is right here. Keep in mind that e to the negative x is always positive, so I don't need to worry about it. Now if I plug 0 in for the x's here, I got 0 squared minus 4 times 0 plus 2 is 2. So it's positive, so it's increasing. Let's try it again. It's positive, so it's concave up. If I plug 1 in here, 1 squared is 1 minus 4 times 1. 1 minus 4 is negative 3 plus 2 is negative, which means it's concave down. Now 4, if I plug 4 in here, I got 16 minus 16 plus 2 is positive, so it's concave up. This would imply that this is a point of inflection and this is a point of inflection. Now where they get these other parts of the answer is they take these two values and plug it back into the original problem, and that gives you the y part.